Hey everyone. So our last section is solids of revolution. Can you believe it? This is the last thing you're going to learn in geometry this year. Anyway, so a solid of revolution is basically you're taking a 2D figure and you're rotating it around a line. So it would be like if I took, let's say, my phone and rotated it around this pen really fast, and it makes a solid. So I know that's kind of hard to explain. So I found a video online that demonstrates it. I actually was going to try to do it myself, but I realized that my drill, you need a drill to rotate it. You'll see. My mom borrowed my drill. So anyway, here is, let me get rid of this. Here is the video that I wanted to show you real quick. So notice this is the drill. This is just like some sort of stick, I don't know, pencil maybe. And then they have a rectangle. So they have this rectangle that they're going to rotate really fast around the stick, and you'll figure out what shape it makes. So it's going to make a 3D figure, and then you're going to find the volume of it. So watch. See how that makes a cylinder? So it might be kind of hard to see, but picture the rectangle as it's being rotated. Try to picture like it almost like recording, or like try to picture the path being like recorded or not recorded. Try to picture the path of um, the rectangle being rotated is like leaving, it's like filling in this solid. I don't know if that makes sense, but that one makes a cylinder. Next, they're going to do a triangle. So if you take a triangle and rotate it around really, really, really fast, see how you get a cone? So again, like picture like the path is like leaving that trail and it's creating the cone, it's filling it all in. Semicircle would make a sphere. So it's pretty cool. I thought this was a good visual. Still sometimes kind of hard to wrap your head around. So I'm going to go through a few examples with you here, and then I'm going to go over to the practice that you're going to do. I'm going to explain a few of those. Okay, so here's another example of what a solid of revolution is if you've ever been through like a revolving door. If you could picture like as the doors spin around, they create a cylinder. So each of these things that we're going to do, the shape is going to create a solid. Your job is to figure out what solid it creates and then find the volume of it. Okay, here's the first one. We're going to take this triangle and we're going to rotate it around this vertical line, and it makes a cone, as you can see. Like I said, on the practice that you're going to do, you're not given this part. You're just given the 2D shape, and you have to figure out what it makes. All right, so volume of a cone, if you remember, is the area of the base, pi r squared, because it's a circle, times the height of the cone, and then divided by 3. So the radius of this cone is 3. So this is going to be pi times 3 squared times the height of the cone, which is 4. And then that's over 3. And so if you're going to put that in your calculator, you're going to first do order of operations. That's 9 times pi times 4. And then divided by 3. And you get that it's approximately 37.7 cubic units. So that's the first one. Next, look at this note right here. It says if the 2D figure or portion of the figure is shaded, then the portion of the 3D figure will be solid when the revolution occurs. So then that portion is what I meant. So basically what that means is if you take a look at this one, just a semicircle that was completely filled in would just be a sphere. But this is a semicircle with another white semicircle. So the white part is not going to be included in your solid. So the white part would be hollow. So picture almost like a gumball, how it has like the thick like gum part and then the inside is hollow. So see, it says solid sphere with hollow center sphere. A cross section just means like if I were to like slice this in half, that's what it would look like inside. So move this mouse out of the way. Okay, so basically what this one's going to be is you have the big sphere. Whoops. Oh my gosh. you have the big sphere. That would be like as if this whole thing was filled in, and then minus the small sphere. Okay, so remember the volume of a sphere is 4 pi r to the third over 3. So the radius of the big sphere would be 5. So this is going to be 4 pi 5 to the third over 3. And then the small sphere, the radius is 3. So it's going to be 4 pi 3 to the third over 3. So this turns into 4 pi 5 to the third over 3 is 523.6. And then this one, the small sphere, is 113.1. And subtract them, and you get 410.5. And this is cubic units. Okay, so sometimes you might have a portion of it that's not filled in, and then you have to think about what it would create. All right, next page. The first one on this page is called a torus. It has a name, actually. It's like a donut-shaped figure. So basically, sometimes a shape, a 2D figure, is not like right up against the line. And when that happens, there's a hole that's created. So this hole is a curved one because this was a circle. We're going to do some too where it's like a rectangle, so it's not quite curved. It's like a cylinder inside, and I'll show you that in a minute. So where this formula comes from, if you take a look, this is the formula right here for a torus. Let me zoom in a little. We have, it's pi r squared, which is the area of this circle, times 2 pi r. This capital R stands for the radius of the path circle. So like this circle. So the reason why, remember 2 pi r is circumference. So this is the area of the circle times the circumference of this circle, the big circle, which makes sense because that little circle is being spun all the way around. So you multiply them. So let's plug in everything. So we have the small r is 2. So this is going to be pi times 2 squared. So it's the area of the circle times the circumference of the path circle. So it's going to be 2 pi, and then the radius is 4. So that's going to be 4 pi times 8 pi, which turns out to be approximately 315.92 cubic units. Okay, so that's the torus or the donut shape. This last one, we have a rectangle being spun around. So it's always a good idea for you to draw the other side to kind of visualize like what it's going to look like, and just keep in mind that it's always a curve. So see how that creates this. So this is not typically given to you, just in these examples we gave it to you. Anyway, so this is a cylinder. So remember the volume of a cylinder is the area of the base times the height of the cylinder. So the radius of the base would be 3. So we're going to have pi times 3 squared times the height of the cylinder, which is 4 units. So plug that in, and you end up getting 113.1 cubic units. Okay, so those are all the examples I had for the notes. I just wanted to put the practice underneath here just to explain a couple of them and kind of give you some pointers on how to do them. So first of all, this practice has 9 questions. I'm going to have you guys choose any 6. Definitely choose at least one on this last page because those are the trickiest, I think. So my suggestion to you is to draw the other side of the shape, like when it's rotated, to try to like draw the solid. So you also really want to pay attention to which axis it's being rotated about. So like this first one is rotated about the y-axis. So that would look like this. And then this is a curve, right? So try to picture what that would be. See how that would be a cone. Then this one, number 2, is rotated about the x-axis. So that's like rotated down this way versus this way. So it's rotated down about the x-axis. So this one would actually also create a cone, but it's just on its side. So also a cone. Number 3 is sort of like the torus, but there's actually kind of a more accurate way to do this one. So picture what this would look like. If this was spun around the y-axis, this is going to basically like, you're almost doing like the reflection of it to picture it. So this would be shaded too. This would be white. So picture like what shapes this would be. Remember that it's curved, right? So this is all curved. So see how it would be like a cylinder. Like if this whole thing was shaded in, if this was all the way against this, the whole thing would be a cylinder. And then it's going to have another cylinder inside. So that's how I would do it, is big cylinder minus small cylinder, because the white cylinder is not part of your solid in the end, if that makes sense. Okay, so that's that one. Sometimes, like in number 4, you have multiple solids. Like this is being rotated about the x-axis. So picture like this would be a little cone, and then picture this would go to here. So this one's basically like 2 cones, find the volume of each one, and then just add them together. Sometimes like in number 5, like picture, this is going to be like here. So here's an example of where only part of it is hitting the y-axis, right? So picture like if this whole thing was filled in, it would just be one big cylinder, right? If this whole thing was colored in, but it's not. So then picture what shape do we have to subtract? There's that one. Number 6 is just like one we did on the notes. And then these are a little trickier. I'm going to let you guys just try these. But again, just like I would highly suggest that you draw the other side of it so you can kind of visualize like what it would be. Keep in mind that these are all curved. Okay. So I'm going to stop there because I want to leave some for you to figure out. I kind of did a little bit too many of them, but that's okay. And so that's that. Just let me know if you have any questions. Come to our Zoom meeting. Like I said, this is our last section of the year, which is crazy to think about. It's the last topic you're going to learn about in geometry, which is also kind of sad because I miss you guys and I miss our class. But anyway, the last day of class, which is Tuesday, we're going to have an assessment. It'll be your last one of the year, and it'll be on volume, surface area, a little bit of area of like regular polygons, and then the solids of revolution. I don't quite know if it's going to fully count for like a test because I feel like this is kind of a short unit, but definitely like a bigger quiz. All right, so that's it. You guys have a great day, and please let me know if you have any questions.